Hello and good morning, grade 9. We do Mr. Samir Awad, and we are going today to start chapter 4, lesson 1, which is atomic structure. And in the atomic structure, we are going to know more about the scientific theories, talk about the structure of the atom, and what is the atom know, in more wide definition. And we will get, guys, first of all, yeah, how the scientists take the point of view of the structure of atom or what is definition for atom. Okay, so number one, we'll start there in part one, talking about Democritus and Daltons or John Daltons. Let's start. So first of all, how do you study something that you cannot see? Similar how you might study a gift wrapping, present scientists, and often study things that cannot be seen with the naked eye. So you cannot know what is inside the present and start to wrap it, but you cannot know, like scientists cannot see what's happened by the naked eye, but you can study. Early models of the atom was in the beginning, and how did the concept of the atom change from the time of Democritus to the time of John Dalton? That's what we are going to know more about. First of all, an atom is the smallest particle of an element that retains its identity in chemical reaction. So if I want to know about the identity, what this element is, I have to get back to its construction of the atom itself. And after that, although early philosophers and scientists could not observe individual atoms, they were still able to propose ideas about the structure of it. Yeah. Democrats. And Democrats, we start here the atomic philosophy. Yeah, because he was a Greek philosopher, 460 before Christ, yeah, to 370 before Christ. So he was among the first to suggest existence of atoms. And Democritus reasoned that atoms were indivisible and indestructible. Yeah, let's get back, guys, to the word atom. If we get to the word atom in the Latin language, we'll get it consists of two parts. Like I said before, a and ton. A, it means in, and ton, it means divisible. So it's indivisible. You cannot divide it into smaller than this size. So if you get any substance and you start to break it down into small particles and small into smaller and into smaller, we'll get by the end to the smallest part, which is the atom. You cannot divide it anymore. Although Democritus agreed with later scientific theories, the scientific theories that we will get with Dalton, they didn't explain chemical behavior of the atom. Also, they also lacked experimental support or proof, because Democritus' approach was not based on scientific methods. We have to know that we cannot say theory of Democritus, but we can say atomic philosophy or point of view of Democritus in the definition of the atom. Dalton's atomic theory. And Dalton's atomic theory, guys, the modern process of discovery regarding atoms began with John Dalton. And John Dalton came after 2,000 years after Democritus. So that's a great evolution happened. So it was in 1766 to 1864, and he's an English and school teacher. Using experimental methods, Dalton transformed Democrats' ideas on atoms into scientific theory, and that's a great achievement. Dalton's atomic theory, Dalton studied the ratios in which elements combine in chemical reactions, and the result of his work is known as Dalton's atomic theory. So we get the ratio between the hydrogen and oxygen inside the water. Like for example, you can say it's two hydrogen atoms to one oxygen. And for carbon dioxide, it's one carbon to two oxygen. And we can say that for a lot of compounds that start to get from two or more elements. And that's the suggestions, or we can say the ideas of Dalton's atomic theory. Number one, all elements are composed of tiny indivisible particles called atoms. And the atoms here are all getting very, very, very small. You can see that later. Yeah, that's example for the atoms of element A. That's for example any element and we call it A. And number two was about atoms of the same elements are identical. And the atoms of any one element are different from those of any other element. So the atoms of element A are identical to each other, and the atoms of element B are identical to each other, but the atoms of element A are totally different from the atoms of element B. And that is the idea. The atom is unique structure for each element. No element can get the same structure of the other one. No element can get the same atom of the other one. So they are totally different. Dalton's atomic theory, we can get number 3n, and atoms of different elements can physically mix together or chemically combine in simple whole number ratios to form a compound. So let's get it part by part. Number one, physically mix. It's like you get in the air. You will get oxygen atoms and you will get, hydrogen, and you will get the atoms of nitrogen. All of these gases, you get it. The atoms of them start to be mixed physically, so you can separate them physically. But on the other side, when two elements start to combine together, like hydrogen and oxygen, in order to make a new compound by a simple whole number ratio, like 2 to 1, 2 hydrogen to 1 oxygen, in order to make the water. So that we can say, guys, it will be chemical combination to make a compound. And that's example for that. Number 4, chemical reactions occur when atoms are separated from each other or joined or even rearranged in different combinations, and the atoms of one element are never changed into atoms of another element as a result of a chemical reaction. So in the beginning, when we can say that if I get two elements to join together, if I start to decompose or separate two elements from each other in that compound exactly, rearrange them inside the compound, so I'm getting a new structure of the compound. So when I change any chemical structure here, it's chemical reaction. But on the other side, I cannot change element into another element. For example, I cannot get back to change A into B or B into A. That's not possible by chemical reactions. You can get it later by nuclear reactions, but that's not possible by chemical reaction. In chemical reaction, every element is the same element, not changing into another element, but it starts to combine with other element to make a compound. So how was Dalton able to study atoms even though he couldn't observe them directly? What evidence did he use to formulate his atomic theory? So Dalton studies the ratios in which elements combine in chemical reactions, and he observed that when atoms mix, they maintain their own identity unless they combine in a chemical reaction. So there is a difference between mixing, it's a physical change, and the combination, it's another chemical change. So how was Democrats' idea as of the atom different from Dalton's one? Like we said before, that Democrats was a point of view that's a philosophy or atomic philosophy didn't depend on even experiments exactly excellent and scientific proof or scientific principles to work on. So here, Democrats' idea did not explain chemical behavior and was not a scientific theory because it lacked experimental support. Using experimental support, Dalton's transformed Democratic ideas about atoms into a scientific theory that explains the chemical behavior by the ratio of the elements inside the compound. So, thank you for listening, guys of grade 9. Next will be part 2 about sizing the atom and what are the instruments we are used to observe the individual atoms. See you later, be safe at home, and see you soon.